Welcome to Mikab Model College online tutorial. We hope at the end of this lesson, you will have acquired the expected learning outcome. Sit down and listen attentively as we introduce your subject teacher.
Welcome to chemistry class. I am Saliu Abdul Wahab, your chemistry teacher. In this lesson, we want to look at isotopy and isotopes. Isotopy and isotopes. Remember, in our previous lessons, we discussed the Dalton's atomic theory. And one of the postulates of John Dalton is that atoms of the same elements are exactly alike and differ from atoms of other elements. Contrary to Dalton's atomic theory, that atoms of the same element are exactly alike in every respect, scientific discoveries have shown us that atoms of the same element may not be exactly alike. They may differ in their masses. Hence, the concept of isotopy and isotopes. Therefore, what is an isotopy? Isotopy is a phenomenon. Isotopy is the existence. Isotopy is the occurrence of two or more atoms of the same element with the same atomic numbers. Remember, we are familiar with the word atomic numbers. With the same atomic numbers, but with different atomic masses or with different mass numbers. We are familiar with atomic number and mass numbers. So the phenomenon, the existence, the occurrence of elements, atoms of the same element for that matter, the same atom, but with the same atomic number, different atomic masses, is termed as isotopy. Atoms of the same element with similar atomic number but with different masses or different numbers is called isotopes. Now, don't confuse both isotopy and isotopes. Atoms of the same element with the same atomic number but different atomic masses are called isotopes. While the occurrence, the existence of atoms of the same element with the same atomic number but with different atomic masses is regarded as isotopy. In isotopic elements, the difference is just the number of protons, electrons, and the number of neutrons. But when you look at it closely, the number of protons and that of electrons are equal. Remember, we have established the fact that number of protons and number of electrons are always equal for an atom to be electrically neutral in our previous lessons. The only difference between isotopic forms of element is in the number of neutrons. It's in the number of neutrons. The concept of isotopy explains why the relative atomic masses of some elements are not whole number. Why? Because the mass of one isotopic form contributes to the relative atomic mass of that element. The mass of another isotopic form contributes to the relative atomic mass of that element. Therefore, when we talk about the relative atomic masses of elements, we will be looking at the contribution of each of the isotopic forms. Therefore, the relative atomic masses of some elements are not whole number. For example, chlorine occurs in two isotopic forms. Chlorine has two naturally occurring isotopes, which are chlorine with atomic number 17, mass number 35, and chlorine with atomic number 17, mass number 37. The first isotope that has a mass number of 35, to deduce the number of neutrons now, all you do is 35 minus 17, which means mass number 35 minus number of protons 17. The first isotope has a mass number of 35, 17 protons and 18 neutrons. How did we have that 18 neutrons? 35 minus 17. And the name of this isotope of chlorine is called chlorine 35. It is called chlorine 35. For the second isotope, it has a mass number of 37. The number of protons remains the same because we said atoms of the same element with the same atomic number but different mass number. The number of protons remains 17. To get the number of neutrons now, we say 37 minus 17, mass number minus number of protons. That gives us 20. Therefore, the second isotope of chlorine has 20 neutrons, and it is regarded as chlorine 37. Chlorine 37. Therefore, chlorine exists in two isotopic forms, chlorine 35 and chlorine 37. Note, to determine the number of protons, like I told you, to determine the number of electrons and protons, use this formula. Mass number is equal to number of protons plus number of neutrons. That's mass number. Number of protons plus number of neutrons. And number of neutrons is equal to mass number minus number of protons. Mass number minus number of protons. Example number 2. Oxygen has two isotopic forms. It has two isotopes, which are oxygen with atomic mass 16 and atomic number 8, and oxygen with atomic mass 17, atomic number 8. The first isotope with mass number 16 is called oxygen 16. It is called oxygen 16. And the second with mass number 17 is called oxygen 17. You may be wondering, why is it not called oxygen 8? Remember that they are atoms of the same element, oxygen, oxygen. The same atomic number 8, 8, but different atomic masses, 16, 17, and which makes them isotopes. Therefore, the difference in the two isotopes is what we use in identifying the two isotopes, oxygen 16 and oxygen 17. Question number 3. Carbon has 3 isotopic forms. Remember, we defined that it is the existence of 2 or more elements. It may not necessarily be 2, it can be more than. As in the case of carbon, there are 3 isotopic forms of carbon, which are carbon with atomic mass 12 and atomic number 6, carbon with atomic mass 13 and carbon with atomic number 6, carbon with atomic mass 14 and carbon with atomic number 6. Therefore, the first isotope is called carbon 12 isotope. The second is called carbon 13 isotope, while the third and the last is called carbon 14 isotopes. Example number 4, hydrogen Hydrogen also has 3 isotopes, which are hydrogen 1, hydrogen 2, and hydrogen 3. Hydrogen 1 has 1 proton, and it also has atomic mass 1. Hydrogen is the only element in the world that has no neutron. Hence, hydrogen is usually regarded as a proton. Hydrogen is usually regarded as a proton. Looking at the first one, the first hydrogen, which is the isotope now, it has atomic mass 1, atomic number 1. Look at it. The mass number and the atomic number are equal, which means that the number of protons and the number of electrons are also equal, but then no neutron. Hence, hydrogen, when it exists in this isotopic form, it is called a proton. It is called a proton. That is, the first isotope is called protium, from the word proton, hydrogen with atomic mass 1, atomic number 1. The second isotope is called deuterium, hydrogen with atomic mass 2 and atomic number 1. Look at the word deut, 2. The third isotope is called tritium, hydrogen with atomic mass 3 and atomic number 1. Tri, from the word 3, and hence it is called tritium. Don't forget, the 3 isotopes of hydrogen are protium, deuterium, and tritium. Remember, hydrogen with atomic mass 1, atomic number 1, is called a proton because it has no neutron. It has no neutron. Now, on this note, let us take this assignment. Deduce A, number of protons, B, number of neutrons, and C, number of electrons for examples 2 and 3 that we have seen in our previous examples. So, subscribe, get those elements, and then work on their number of protons, their number of neutrons, and their number of electrons. It can be very, very sweet when you are doing this. Don't forget to please subscribe to this channel. I remain Saliu Abdul Wahab. Thank you very much.